Warm welcome you all. I am Professor Jebash Samuel, Assistant Professor, Department of EEE, Rohini College of Engineering and Technology. So, in this topic, a presentation, we are discuss about the concepts of inverter. That is the various control techniques of inverters. What do you mean by inverter? So inverter is a device which converts DC voltage into AC voltage. Okay. So there are so many classification of inverter. So based on the input supply, which is classified into single phase and three phase inverter. So based on the connection, which are classified into series and parallel inverter. So in all kind of inverter, we are using some control techniques. So the motto is to control the output voltage of inverter. So in inverter circuit, we are using pulse width modulation techniques to control the output voltage. So what do you mean by pulse width modulation? It is a control technique used to control the output voltage of inverter by properly controlling, that is properly turn on and turn off the semiconducting devices which are inside the inverter circuit. Okay, so in this chapter we discuss about the pulse width modulation technique, how the voltage can be controlled. So in the pulse width modulation inverter, the width of pulse, so the applied gate voltage, that is the pulse over the output cycle, which vary in a proper manner. So in this concept, which involves a comparison of high frequency triangular carrier wave with a sinusoidal modulating signal. Okay. So pulse width modulation is normally classified into single pulse width modulation, multiple pulse width modulation, sinusoidal pulse width modulation, and modified sinusoidal pulse width modulation. So in this pulse width modulation method, a constant input DC voltage is applied to the inverter. It is from a constant DC source, the inverter get input voltage and a controllable AC voltage. That is the main concept. The controllable AC voltage can be obtained by means of pulse width modulation technique with a desired frequency is obtained. So it is accomplished by adjusting the turn on and turn off time period of inverter switching device. So this is the pulse width modulation technique. That is multiple, one of the pulse width modulation technique, multiple pulse width modulation. So multiple pulse width modulation means for each and every cycle multiple number of pulse generated. In single pulse width modulation, only single gate pulse can be generated. Here multiple number of pulse width modulation, n number of pulse can be generated. So already I mentioned the pulse width modulation technique is the comparison methodology. So here two signals, one is carrier wave and another one is reference wave. Two signals are compared and based on this concept the pulse can be generated. So the pulse width modulation control methodology is a feedback control. That is the output voltage can be always sensed, the output voltage of inverter can be always sensed, and if there is any variation the width of pulse can be varied. Okay. So here in multiple pulse width modulation, the reference signal is a DC voltage that is indicated by a straight line, and the carrier signal is a triangular wave. So these two signals are compared. Okay, and based on the comparison, the gate pulse are generated for positive half cycle as well as negative half cycle. So based on this concept, the gate pulse is given to the semiconducting devices and the output can be properly controlled. Similarly, the pulse width modulation having sinusoidal pulse width modulation technique. Instead of this triangular wave, instead of the DC voltage, we are compared a sine wave with a triangular wave. In concept, the reference voltage is a sine wave. Okay, pulse width modulation, concept of pulse width modulation technique. So based on this the output voltage of inverter can be easily controlled. Okay, thank you for your patient listening. Thank you.